Welcome back once again. So we're doing indices and logarithms, and we are on rule 3 on how to multiply indices or powers of a number. So what you're seeing here is the rule number 3, which says a to the power m, or all these are in brackets to the power n again. So what does that mean? Just multiply what? Powers. The result will be a to the power m times n. And here's an example, 2 to the power 3, right? Then it's all squared, or it's all multiplied by 2. It's just repeating 2 to the power 3 multiplied by 2 to the power 3, right? So you just multiply the powers, 3 by 2, you get 2 to the power 6, or you can do what you've done earlier before of adding. Since 2 to the power 3 squared means 2 to the power 3 multiplied by 2 to the power 3, check the common base, 2, then the powers will be 3 and 3, so you say 2 to the power 3 plus 3 gets 6, that's the same. And then the result is 64. Rule number 4. Here we have different bases. A to the power n and b to the power n have different bases, but the powers are the same. The power n is the same. It's common to both bases a and b. So what you can just say is like enclose a and b into brackets and then put the power n. So they are being multiplied by the same power. So you just close them in the bracket, then raise to the power n once. That's the same like 3 to the power 2 times 4 to the power 2 is equals to 3 times 4 or what squared or to the power 2, and you get 12 squared, which is what? 144. Likewise, when you're dividing, if we are dividing different bases, that is a and b are different, right? But they have the same power. We just enclose all in one bracket, a over b n, a over b, then to the power n. That is if b is not equal to 0, because you can't divide by 0. Then the same here, another example, 3 to the power 2, 3 to the power 6 to the power 2 divided by 3 to the power 2. It's like we put 6 and 3 into one bracket, then you raise to the power 2. Then in the end, you first divide this one, 6 divided by 3, you get 2, right? So it will be 2 to the power 2 equals what? Equals to 4. So also here, like there are some examples which you can what simplify so that you understand the above rules you're talking about of indices. So here b is equals to what? X to the power 1/4 times what? X to the power 3/4. So we are using the rules of what? The common base. We have a common base, but what? Different powers. So you check x is common both, right? Check x, then you add what? Powers. 1/4 plus 3/4 is what? 4 over 4, which is what? The same as 1. Then get x to the power 1. So b becomes what? B is equals to x. And here, if you have b is equals to x squared divided by x to the power 3 over 2. So here the base is common. So here we are dividing, they're using the rule of what? Dividing, right? So say x is equal to 2 minus 3 over 2. When you're dividing what? We subtract. So 2 minus 1.5. 3 over 2 is like same as 1.5. So it become what? 1.5. So it's like x is equal to 1, x to the power 1/2. That would be the final answer if you work it out. Here b is equal to what? 3/4, then in brackets to the power 8. So it means you multiply what? Powers. So 3/4 times 8, it will be what? 6. It will be 3 times 2. So our x, the base remains the same, x, and then the power will be what? 6. And here, if we have x squared y cubed x4 multiplied by y. So first simplify this one. First divide the same terms like x and x. X squared, x4, we subtract, right? It will be 2 minus 4. It will be negative 2, right? So x squared, if it is negative 2, you bring it down. That is x to the power 2. It's same as what? X to the power negative 2. Then y, you go on to y3, y1. y1 divide the y3. So it will be 1. You get what? Y squared. So y squared, x squared. That's how we write the final answer. Then after that, since the power is common, you put all in brackets y over x, then you put this common power 2 because it's being found on the numerator and the denominator. Okay, so we are done with indices. So the next chapter is about logarithms. So like the next subtopic is logarithms. So we are going to take a break and then we'll come back for the logarithm video.